Good morning, good afternoon, and good evening to everyone. Welcome back to our SoBigData Digital Coffee. It's a pleasure to see so many of you connected once again. For those of you joining for the first time, let me present myself. I am Giulio Ferrigno, Senior Assistant Professor of Innovation Management at Scuola Superiore Sant'Anna, and I have the great honor and privilege of moderating this webinar series alongside my wonderful colleague, Maria Giulia Garcea. I would also like to express my gratitude to SoBigData Research Infrastructure for giving us the platform through which we can organize this webinar series. And special thanks goes to Valerio Grossi, Michele Natilli, and Roberto Trasardi for their incredible support in making everything possible. In this webinar series, we are focusing on a very concrete real-world applications of big data in 4 key sectors that shape our daily lives: healthcare, tourism, media, and finance. Last time, we talked about the relevance of big data in healthcare. It was an incredible session, and we had so many good insights from our international speakers. And if you missed this session, you can go to the YouTube channel of SoBigData Infrastructure. Today, we are going to talk about the relevance of big data for another important sector, the tourism sector. So, as usual, we've got some outstanding speakers lined up for you today. But before we jump into the conversation, let me just briefly explain you the format, especially for those of you joining us for the first time. In each of the webinars, we are always trying to bring 3 different expert speakers representing different perspectives. Sometimes we have academics, other times data scientists, other times managers. So in order to give you a well-rounded view of the topic. And each speaker has about only 10 minutes to present. And after the presentation, we will have 15-20 minutes of Q&A session. Therefore, if you have any questions, please use the chat. Use the chat to write your questions. Don't be shy. Speakers are very, very happy to answer to your questions because we want to advance our knowledge, the conversation towards this topic. So, just like in the previous episodes, we will read the questions at the end of the webinar, and the speakers and me will address this question. Of course, let me remind you that the session has been recorded, is recorded, and will be available also on the YouTube channel of the SoBigData. So if you miss any part of the webinar, you can watch it later. Don't worry. Additionally, let me remind you that because of you are joining these webinars, we want to give you our appreciation for this. So you will get at the end of the webinar series a digital copy of the SoBigData magazine for free. You don't have to pay for this, okay? It will be for free, but it will be released at the end of the webinar series. Plus, as I already introduced you this new last time, since you are joining this webinar, you will also get a free, a free certification of attendance. So you will get the certification of attendance at the end of these webinars, okay? So, having explained you the format, let me go back once again to the topic of this webinar, which is about the importance of big data for the tourism sector. So big data is indeed, we are focusing on the tourism sector because big data is indeed reshaping tourism, by providing very unprecedented insights into traveler behaviors, into their also preferences. Think about tourist marketers. Big data enables the creation of personalized offers, helping to attract and retain also travelers by tailoring experiences to individual tastes. With tools like predictive analytics, businesses can optimize pricing, forecast the demand, allocate resources more effectively. especially when we have, for example, high demand seasons. And smart mobility solutions are, of course, play a key role in this, because they enhance, for example, tourism experience by enabling seamless travel through real-time navigation, transportation insight, and so on. This integration of big data and also the smart mobility indeed foster smarter, more responsive tourism marketing strategies that meet travelers' evolving expectations. But other things would be, for example, smart cities. So, but I mean, we can talk for this for so long time. But now it's time to give the floor to the speakers we have involved today. So, Maria Giulia, indeed, to better understand this issue, we have involved three outstanding speakers today. Is that true?
Yes, it's true. So, hello everyone. Today we are very pleased to involve three amazing speakers. So we have Giovanni Mauro, Daniele Tortora, and Susanna De Luca. So now let's go into our first presentation, and I'm very happy to introduce to you Giovanni Mauro. He's born in 1995 in Catanzaro, and he holds a BSc in computer science from University of Pisa, and then from Universitat Politècnica de Catalunya in Barcelona Tech. He's now a research fellow at Scuola Normale Superiore and a PhD candidate in the Italian National PhD in AI. His research focuses on developing algorithms to analyze and predict human mobility patterns, including daily travel and housing relocation phenomena like aggregation and gentrification. So please, Giovanni, first of all, thanks for being with us today. If you can please share with us your experience as researcher.
Of course. Thank you, Maria Giulia, for the introduction. Can you see my screen?
Yes.
Okay, perfect. So let me start. So hello, everybody. I know almost for sure that most of us live or work in a city, and we know that these cities are complex systems. I mean, at a certain point, we can decide to trust these entities and say, yes, okay, the systems will regulate towards a social good. We have nothing to do. Or we can accept the fact that they will show some strong inequalities. Specifically, what do we see? We see traffic, we see pollution, we see epidemics, we see housing inequality, economic inequalities, or visits to place inequalities. Generally, what I'm doing is, through the lens of a human mobility analyst, I'm trying to study the complex mechanisms that regulates this complex system that is a city, with a special focus on the phenomena of gentrification and generally human AI interaction. So I want to introduce two projects that we are working on. The first one is called Dynamic Models of Gentrification, a joint work with University of Oxford. Gentrification was defined in 1964 by Ruth Glass as this phenomenon for which basically poor people are displaced by middle income and high income people. I should convince you that it's a pressing phenomenon, but I prefer to show you some photo I myself took during my travels in Europe, and you can see that indeed, yes, it's a pressing problem. It's hard to measure gentrification because basically we are measuring the invisible, as Roland Atkinson said, because you don't know when you watch a data if you are observing a replacement or a displacement. And generally, it's very hard to get this kind of data. You can trust me. A lot of work study the presence, for example, of Airbnb or other proxies. There are several theories of gentrification. An economic one that is rooted in this concept of rent gap, the difference between the current price of a house and its possible future value, or some sociological theories that say that first are the artists and students that are attracted to from a low-income neighborhood, then middle income come in, families attracted by the vibrancy of the places, and then at a late stage, investor group joins the game, basically changing the face of a neighborhood. We want to model this phenomenon. We want to have to respect three quantities. Basically, we want it to be low parameters so that we can understand and explain what is going on. We want to base it only on people choices and economic conditions, so to respect both theories, and we want to focus it on the temporal multi-layer network of relocation, inspired by Thomas Schelling's seminar work of 1971. Basically, we modeled the city as a chessboard in which three types of agents live. A low-income one that decides to relocate if it is too poor, and goes in a place when it can afford it. It is in places where its income will be more likely into the higher part of the income distribution. The middle income agents want to stay middle. We want this model to be as simple as possible, so they move if their income percentile is too extreme, and they move in a place in which they can continue to be middle income agents. Instead, high income agents basically observe the trend of the city, and at a certain point they will move with a probability pH. They will go into the places that are growing the more, so ignoring all of the other movement as super high income, the 5% of the population of the city can do. Basically, we observe three things in this simulated scenario, and it is that if we observe gentrification by counting how many low, middle, and high income agents are in the cities, and we just use this as a proxy, fixing a threshold, basically we are late with respect to observing the flows of these three agents with a mathematical formula that I won't show you because it's quite boring, but still, we have a way for having an early warning signal of gentrification just looking at the network of relocation. Here is the peak. Second result is that even if gentrification is defined by mainly middle income that substitute low income agents, if super high income agents don't move, it is a probability of 0,0 of moving, the gentrification does not happen in our simulated scenario. And three is that the more the city increase in population, the highest the probability of observing gentrification phenomena. After that, we asked ourselves what happened if this simple yet important scenario, because even from simple rule, I can assure you that complex mechanism and complex relationship emerge. We want to complicate it a bit and ask ourselves, yes, but we are in the age of the AI. What happens if the AI joins the urban game? We know, in fact, that in urban scenarios, but generally in our lives, are very permeated by these recommended systems, that are the systems that provide suggestions to user, for example, item, location, post, or user, and more or less shape a lot of aspects of our life, more specifically the urban mapping. So, for example, Airbnb or Google Maps or a lot of other recommended systems. Among this family of recommended systems, a family that is particularly useful are the next POI recommended system. It is a recommended system that suggests user where to go basing on their history. Basically, how do they work? They exploit this thing called interaction matrix, so they can feed a neural network or a recommended system, whatever, and so that they can provide suggestion to the users. The question is, what are their long-term effects on the urban environment? How do they interact with local people? Do they foster phenomena like segregation or gentrification, as we saw, or could they amplify some venue popularity? Specifically, we ask ourselves, what's the impact of recommended system of POIs, that is point of interest, visitation patterns? In fact, based on previous studies we did, we know that recommender systems are into this feedback loop. They are trained on some training data that are generated from the user choices, and they provide this suggestion. The problem is that this suggestion will influence the next user choices, and this will result in a loop that can be potentially malicious. How can we study this feedback loop in an urban environment? Well, ideally with an empirical control study. We should have and should know who is receiving suggestion and from which, but it is impossible because big tech or governments or nobody will give us this data. So basically we implement a simulation framework for simulating the feedback loop for next POI predictor. Basically we have a data set we use to train a next POI recommended system, and we will suggest some next POI to visit to a portion of agents or inhabitants. And we implement also the possibility in which people decide not to follow this feedback loop. And we repeat this more and more, bearing the penetration rate, so the probability P, and we look at what happened. Basically, we implement 3 types of recommender system. The user collaborative filtering, it is we suggest to people to go where similar user went. Item collaborative filtering, it is we suggest to visit similar item with respect to the one you visited, and an AI-based approach of particular kind of collaborative filtering. Also, we postulate that if a user refuses this suggestion, can either go to its most visited places, that is individual popularity, or can go into a random places he previously visited. What we observe is that in the long run, we observe a really high reduction in the number of distinct items suggested, but this phenomena at a collective level is slowed down by the penetration rate. It is the more AI joins the game, the more it seems that it controls this phenomena of suggesting the same places more and more. But we have to say that at an individual level, it is true that relying more on a recommender system increase the diversity, but we are not able, since we are not the owners of the platform, to understand how this will decrease anyway. So the relationship among these factors is really complicated. Summing up, even simple urban dynamic simulation yields complex results, as we saw in the gentrification. The problem of the data is pressing, so we need to simulate to understand what is going on. But this is good, because in a simulated environment, we have the possibility of isolate effects. Generally, AI algorithms permit our lives. And if we investigate how and why the popularity of suggestion and the difference in suggestion increase or decrease due to AI, we can contrast the phenomena of over-tourism or generally of visits inequalities. That's it for me. I should have stayed in 10 minutes. These are my contacts if you wish to know more, or if you have any other question, I am happy to address them later. Thank you.
Thank you. You are perfect in time. So I'm very impressed, and I think also the people that are listening to you about all the research and the work that you have conducted, and the team of SoBigData research infrastructure on this topic. So thank you again for your presentation. And please, anyone that is listening, feel free to ask Giovanni and all the other speakers any kind of question. You can write in the chat, and in the end of this hour, we can answer. They can answer your question. But now let's see another point of view. The point of view of a company that also works in the SoBigData research infrastructure. So I'm very happy to introduce to you Daniele Tortora from Octotelematics. So Daniele joined Octotelematics in 2014 as Global Head of Product and Service Management. The role has the aim to create and develop innovative service roadmap based on telematics, defining value relational, data modeling, and analytics in a big data and IoT environment. He focused on digital delivery and customer experience. He also contributed to develop an IT capabilities and support Octo patent process, applying machine learning and AI techniques. So please welcome Daniele. So thanks again, Daniele, for being with us today. What is the relevance of smart mobility in this context? Please, if you can share your slide. Thank you.
Yeah, thank you, Angela, for this introduction. Just let me give you a little bit or more in terms of figures about Octotelematics and what actually we do in our business verticals. We are in the market of telematics since more than 20 years. In more than one of the geography in which we are operating, we are considered as a telematics service provider, ranked as a first ranking. We have, but the story in Octotelematics is obviously related to a long history of collection of data. basically on the connected car. So basically, we have an history of more than 600 billion of kilometers of driving data, more than 92 billions of total trips that has been registered in our data lake. We have been, during our history, more than 6 million of connected car and all users that is driving car. Just to give a little bit of background, when we are talking about connected car, we are talking mostly of private car. Okay, so the cars that we are usually in the smart cities. And we also have another pillar in terms of detection of crashes. We have more than 500,000 of certified crashes that has been registered into our Octo platform. Just to give a little bit of, again, of background, we have more than 50 years of collaboration with public and private company research, as we have, as we think that is a crucial for facilitating rapid adoption of the education on using the big data and a data-driven culture. So what are our mantra, I would say, is the fact that we are using car sensors in terms of sensors that are moving inside the cities. And we have started thinking on using those data from the sensor inside the car to analyze the impact on the smart cities. We have made a lot of use cases on London, on Boston, in Milan, Rome. So basically, where all the cities and geographies where we have enough data to be analyzed from the connected cars. We are basically operating in 4 different business verticals. One is the support mainly that we provide to the InsurTech. The other one is the fleet and car sharing and rent car companies. The third one is the automotive, as a wide concept of the automotive, and also most recently on the smart cities. And everything of this kind of mobility ecosystem is based on the analytics and AI application on the raw data that we have been collected, that we have explained so far. So what are the solution, the customer benefit that we provide on the business is for motor insurance. We are on top of providing pricing risk for insurance company that are using basically the data, sensor data that is coming from the cars, from the vehicles that is being driven, the claims management, and also customer relation. The customer benefit in this case is evident and can lead to a reduction in risk profiles, in fraudulent claims, and more increase the customer retention for insurance company. In the smart mobility, we have application in terms of increase and reduce the total cost of ownership of a car, in terms of operation of fleet utilization and better running process, and duty of care of safeguard in terms of the drivers and the vehicles. This is producing benefit for customer on increasing residual value of the vehicles and reducing crashes even. More recently, in the smart cities domain, we are, as we are going to see in a few minutes, we are supporting some urban planning, digital permits on access on restricted area, and most recently some eco-safe and driving for a sustainable mobility in the cities. So what is the platform that actually we are using for supporting smart cities use cases, and actually we are using for some of the municipalities that we have I have listed before, is what we call is a mobility atlas. And we provided based on the analysis on the sensors of the car that actually we are managers of the famous 6 million that I listed before. We have provided use cases on mobility profiling, EV charging point planning, public transportation planning, and other use cases. I just give you some brief screenshot of the use cases that we have derived. The first one is the analysis of what we call the point of interest, which is an analysis that we made for some municipalities, in this case Palermo municipalities, when we have analyzed the access and the impact of some interest and selected infrastructure. In those cases was a bridge, and we were analyzing some of the metrics and profiles of the drivers or vehicles that have access to this specific point of interest. We have tried to provide some kind of impact on that specific infrastructure that the private traffic flows may have on this specific infrastructure. The second use case that we have analyzed in our Auto Mobility Atlas platform was related to the sustainability dashboard for private mobility. As I told you before, we started to collect those data for risk analysis for the InsurTech. Okay, so what we are trying to get here is actually a sustainability indicator that can be mixed together three different kind of layer or sub indicators. What is what we call the traditional riskiness, so how you are driving, how the behavior of your driving is risky for an insurance perspective. The second one was a measurement of the pollution, and the third one was in terms of efficiency, in terms of energy. And in this slide, you can see that we are able to derive for a certain vehicle and a certain trips made by this vehicle, these three kind of metrics related. The red one to the risk is the pollution of the green boxes. Here we have a sort of eco index with a measurement of a kind of pollution, and the equivalent consumption in terms of kilowatt per hours if those vehicles should be changed in EV vehicles, and those vehicles are already traditional vehicles. So the combination of this one is what I told you before, a kind of sustainability index that we are working on for trying to make a sort of summary of the impact on the use of the private vehicles on the smart cities. The other areas where we have a lot of analysis and we have provided a lot of metrics and insight was related to the famous 500,000 of detected crashes, in order to provide some sort of risk area where the infrastructure of the road, of the streets in general, the city in general, are most detected and be affected by kind of crashes that can be both serious or very low impact one. This is specifically important for municipality, for those entities that has been interested on the safety and security, also who is doing road maintenance companies. Okay, and the other one is the infrastructure planning and a consequent impact analysis that we made in accordance of the municipality that wants to test a sort of what-if analysis before or during and after of construction site alongside some specific routes. So what is happening to the traffic and in terms of metric like travel times, average speed, length of roads, if I open a construction site in some specific area of a city, what is going to be the impact to be, to represent some sort of transparent information to all the city's stakeholders. The other area of interest on which we apply our capabilities and data is to some sort of analysis that we made of the mobility of some area and sub-area in order to analyze a potential impact of introducing access in restricted areas, so famous green area when you want to, a municipality wants to introduce some reduction in terms of access for private car. So specifically, we want to analyze what is most convenient for the municipality and the traffic to consider as the gates of entrance and the access or the exit of those areas, to analyze the flow, to analyze the path and the behavioral of the introduction of this green area. The last one is the mobility flow to drive EV demand. This is specifically for utilities that wants to create infrastructure in municipalities, and specifically charging station for EV. So what the business needs for those was, okay, what are the area which are most eligible to be set for the EV charging station, and what is going to be potentially the demand for EV for the energy in order to be located there. And what we have analyzed basically is based on the connected cars that we have analyzed in some specific municipality. We made some complex simulation in terms of energy needs for EV based on certain parameters. We basically derive a physical model and simulate car battery power, residual charging level for a driver to reach a certain area and to go in the other area, charging duration and distance travel. This what you see here in the screenshot is exactly the screenshot that Mobility Others is providing for the utilities that is actually using those bubbles that you can see are those areas that has more needs in terms of charging station demand. And that's all for me. I'm happy to answer to your question at the end of the presentation. Thank you.
Thank you very much. Thank you very much, Daniele, for your view. I hope there will be some questions for you. We directly go to introduce to you our last speaker. So is here with us Susanna De Luca. So we will see another point of view of the company, another company of Doxa. Susanna De Luca is a senior research manager at BVA Doxa, and she leads the web listening team, and he's the head of Vox, an innovative voice of the experience product based on analysis of unstructured data with AI and machine learning. So Susanna, thanks a lot for being with us today. From BVA Doxa, what are the main insights that you have for tourism and marketing?
Thank you very much. So today, yes, my point of view will be the point of view of different from the previous speakers, because in Doxa, what we do is market research. So we are, for the one who doesn't know who we are an Italian market institute of research. We were born in 1946. We have run our very first research round here was the estimation and the forecast of the referendum monarchy versus republic. So we have quite a long history on market research and sociological research. Since a couple of years, we have been part of an international group. So this is why BVA Doxa. And we are in this recent months, years, very, very engaged into experiment all the new techniques, especially with artificial intelligence that can enhance the market research. We work in any industry. We don't have a specific focus. So one of these industry is for sure tourism. So what I want to talk to you today is my expertise. My expertise in research is web listening. So I do listen what the web is containing in terms of traces, in terms of contents, in terms of posts. And when we talk about tourism industry, we know very well that tourists are leaving a lot of traces on the web in different steps of their journey. They are leaving millions of data everywhere. They are leaving traces before their departure. So searching on Google, where can I go? What can I visit in a certain city? They leave traces on travel blog, accessing to different information. They leave traces during the trip. Think about, for example, the amount of images we can get from Instagram, visit Rome or visit Milan. So you take trace of all the iconographical materials, or on TikTok, the videos. And they leave traces also after the trip, leaving reviews. They leave reviews on all the review sites, so on Booking, on TripAdvisor, on Airbnb. So we are full of this big data that we can, as a web listeners, understand, listen, and analyze. So we do monitor online blogs and opinions, for example, on forums, online reviews. We detect trends. We monitor search data on Google, and we track geolocalization. But as you can imagine, these data are fully unstructured. We are talking about texts, posts, tweet, X, or images, or even video. So we need the help of AI tools to analyze all these unstructured data. So we have on the one side a huge amount of data left by tourists on social media that we have to exploit. We cannot leave this data unused. We do web listening for scraping, for collecting all this data, and we use artificial intelligence for analyzing. What we can get to marketing, tourist marketing, is a better understanding of the travelers' preferences, possibility to tailor the travel experience, to improve the travel experience, to personalize all the campaigns, all the marketing campaigns, and so to modify also the offerings according to real-time trends. In other words, what we can achieve is a boost of the tourist satisfaction and loyalty. I would like to talk about two cases. One is one case I'm really into, because it's the third year that we launched this observatory. Is based on museum, on a panel of 25 museums, Italian museums. We have retrieved, collected all the reviews left on Google and on TripAdvisor in any language, for example, on Pompeii, on Galleria Nazionale, on whatever museum we can, the most principal museum in Italy. We have gathered sort of 150,000 textual reviews. We are not talking about the rate, so the stars left by the users, but the texts that usually are very roughly analyzed, but never really exploit as a full repository of insights, of emotions, of real feedbacks in their own words of the visitors toward the museum. So we collected, we used our internal tool of machine learning for text analytics. And what we have obtained is a taxonomy, so a codification of this large amount of texts made by macro categories and micro categories, and each of these categories has its own sentiment. And then we delivered a multi-client report to all the museums that were subscribing the observatory. As you can see on the right hand, this is the distribution of the main categories. We treat categories as offering. This is macro categories, and then for offerings, we have all the second level of categories: offering, emotions, organization, tickets, service. So, and you see how the behavior of this taxonomy is very different from one museum to the other. You can also see that there are some tendency of the industry itself. So we have learned something on the industry, but we have also given feedback to our clients, to all the museums, in order to better enhance the experience of the client, of their visitors. And we have each item to be plotted and to measure which museum were higher or below the average on each of these statements, so tickets, personal, service, etc. So our approach in this case is a process aimed at capturing all the feedbacks, the attractory feedbacks of the visitors, of the travelers through artificial intelligence. And we do apply, this is the Vox, so our product we have launched, we do apply this approach to any data that the companies can have in its internal data from customer care, data from complaints, data from emails, data from CRM. So we do analyze big data, big number of unstructured data, and we do give this overview to our clients. The second case I want to talk with you is the personas identification. We have a partnership with a very interesting provider who can enrich our data collected through the web listening. Let's pretend we are analyzing travelers. We want to identify the type of travelers of Rome city. With our web listening, what we do is to collect data, posts written by authors on the web, talking about Rome as a tourist destination. So I want to visit Rome, I have been to Rome, I use the hashtag visit Rome, etc. So I collect all these data and run all my analysis on web listening. But what I can also do through AI algorithm based on IBM Watson engine is to enrich this data, and first of all, mapping the clusters, so creating personas, creating some profiles of the tourists so that I can better know who are the tourists that are interested into a certain destination. But not only who they are in terms of socioeconomic, this enrichment, this process of enrichment through this algorithm can also allow me to draw an attitudinal profile, a personality profile of the single targets. I can also better understand their habits, their attitude on the web. Where do they go? Which other sites do they use to look for? Which influencers are they most exposed? Which is their media consumption? Which apps are they downloading? So I really enrich from a psychological point of view, attitudinal point of view, and behavioral point of view, all of my target. This will enable our clients, which can be an agency, a communication agency or a destination, to better target marketing campaigns because they know who they are talking about, especially if they are digital campaigns. So, in conclusion, how can AI help us in general into market research? It is helping a lot because it can enrich our data, also going forward, not only collecting data, enriching, but also giving forecasts of how will this destination will be in the future, which will be the interest, and how the target will gonna change. We do analyze big data, big amount of data in very small time, with small effort, with scalability, and with higher level of accuracy that we never imagined before. Last message I want to leave you is that as a market research institute, everyone now is asking which will be our future as researchers now that AI tools are available. What we really believe is all these AI tools are properly working because there's human expertise train their algorithm. So the synergy must be always there in order to really give the real added value. Thanks a lot.
Thank you, Susanna. What an amazing presentation. I have so many curiosities, questions, but I think we have so many questions from the audience. So let's just scroll the chat and let's read some questions. We are a bit short of time, so let's try to read them very quickly, and let's try to have an answer to each question. Okay, so let me see. A question for Giovanni. Okay, for the first speaker, yes. Do you think that your approach could be the solution to the over-tourism problems generated by OTA platforms, Airbnb, Booking, etc.? I'm thinking about Barcelona, now Florence, and perhaps Rome in Jubileo, for the next Jubileo. Yeah, so if I interpret well this question is that nowadays the OTA platforms are bringing so many problems for the cities because they attract so many tourism. So I think, and then, for example, we had some problems for the Barcelona. I think about some tourists, some citizens' reactions happened in Barcelona recently. So yes, I think Rome's for the Jubileo, maybe next year. So what do you think, Giovanni?
Okay, thank you for the question. It's really interesting. Just about Barcelona, exactly. We are cooperating with Barcelona City Council. Actually, I lived a lot of years in Barcelona, so I know the problem. But generally, I mean, of course, each city is a tale per se. But generally, as a scientist, I can't say that it's the solution. What I can say is that we need to precisely quantify the effect. I mean, it's not enough to say they have an impact. We have to know how much, and we have to be able to disentangle with the penetration rate they have, with the number of users, with the timing. So there's room for work, and for sure, if there is a solution, it will pass through the perfect comprehension of this phenomenon. Thank you.
Okay, thanks, Giovanni, for your quick answer, but also very concise and insightful. And a question for Daniele. It's good to see how smart mobility can be useful to find also pollution solutions. I think that the insight could be useful for Wise Air, which collaborates on many municipalities on these things. What do you think? Well, I don't think this is a question per se, but it seems that there is a company, Wise Air. I think Wise means saggio in Italiano, so good air. That probably, I don't know if you collaborate already with this company, probably could be a collaboration.
Yes, yeah, okay. To strictly answer to the question, I would say yes. Okay, so municipalities has been interested in what actually we are doing with our approach, pairing the pollution, the simulation of the pollution with the sites of station that they have in the municipality to analyze the pollution. They want to get this data, but this is not really, I would say, our approach. What we have found is that there is a kind of correlation on how you are approaching on your driving in terms of riskiness, but also in terms of pollution. So what we are looking for as a Octotelematics is try to find this for the insurance telematics is the most oriented ESG product and solution, I would say. But certainly there is a kind of parallelism that can be used for those specific use cases for the municipality, but is strictly limited to the presence and the coverage of each municipality that actually we have. And unfortunately, we do not have for all the municipalities in terms of connected cars. But yes, we can do it.
Okay. Thanks. There is also a question for you still. So, could your analysis inform policymakers into implementing the 15-minute city urban planning concept?
I would say yes again, okay, but it's a matter of how the policymakers are driving their business. So don't forget that we collect the data for a certain specific services. So that means that the policy holders are signing a certain terms of condition to get back some specific services. So if you want to make this kind of wide implementation that is covering not only insurance risk, but also a wider interpretation in terms of urban planning, I think that we have to involve also other actors on the game in order to change it. But in theory, that can be done. Yeah.
Say it could be in the to-do list for the future.
Yes, exactly.
So, okay.
It's not just a matter of again, it's not just a matter of absence of data and information and capability. It's a matter that the main stakeholder needs to be put together on these needs, in my view.
Okay, thanks for the clarification. And then we have a last question. The speaker has not been written here, but I think that, well, there are some typos, of course, but I think it's directed to Susanna. So if I interpret it well, the digital twins of museums are complementary or parallels for your traveler analysis. So if I interpret well, the question is that probably now we are going to see more digital twins of many things, for example, cities and also museums. But I will give you the floor to answer. But for me, is not probably a peril for your travel analysis in the sense that it will create more data, other type of data that could be analyzed, and either other insight could be derived from this. What do you think, Susanna?
Yes, I'm also trying to better interpret this question, but if I go in the right direction, yes, I do agree with you. It's not a peril. In my opinion, we had to use these technologies in order to better control, monitor, and also detect some some trends that cannot be very enhancing and very positive. So what we can do with our machine learning and artificial intelligence or research or market research is only enriching and only giving us a faster and more comprehensive overview of what is happening. So it's not skewed. We can clean, we can interpret, and we can triangulate with other techniques, other research techniques. But this is an important step in our data collection, data analysis.
Super. Thank you, Susanna.
Thanks.
What a nice conversation here, guys. We're fortunate that we don't have so many other questions because we are very short of time. And as you know, we try to be very on time every time. I think that today we learned so many good things. We had so many good presentations. So I would like to thank our speakers. So thank Giovanni, Mauro, Daniele, Tortora, and Susanna De Luca for being with us today.
Thanks to you.
Thank you. Thank you for inviting us.
Of course, this was possible thanks to the SoBigData research infrastructure. So I would like to thank also the SoBigData research infrastructure for letting me organize this webinar. But this cycle of webinars, as you know, does not conclude here. Let me remind you the following webinars. We have still 2 more episodes of big data in other sectors. So let me remind you that we have another webinar that will be organized on the 20th of November. That will be on the role, importance of data science in media. And then we will have the last episode of our webinar series that will be on the impact of big data on economy and finance, okay? So how big data could drive, for example, investment strategies. So of course, let me remind you that the link will be the same. And for those of you who joined us later today, you can always go on the YouTube channel, watch the video again. It will be, the recorded session will be out very, very, very soon. Let me thank you all for attending this webinar, and have a lovely rest of the day or the afternoon or the evening, okay? Look forward to see you again soon.